All right, let's get right into it. When we talk about solar energy, two words are absolutely paramount: quality and safety. Today, we're diving deep into the Technician's Guide for Solar PV Inverter Testing. This is the critical process that makes sure every single project is safe, totally reliable, and really built to last.
So, think about it for a second. When you look at a solar setup, your eyes go straight to the panels, right? But what's the real brain of the whole operation? It's the inverter. Yep, that box on the wall is the heart and the mind of the system, taking all that DC power, converting it into the AC power we use, and managing everything from performance to safety.
And that's exactly why an untested inverter isn't just a potential problem, it is, without a doubt, a project's single biggest liability. I mean, just one faulty unit could create a lethal shock hazard. It could cause massive delays, lead to super expensive product recalls, or get you an automatic fail on a certification audit. It's a huge deal.
Okay, so here's our game plan. We're going to break it down into a few key parts. First, we'll get into the actual test standard, the rule book, basically. Then, we'll walk through the high-stakes test gauntlet that every new design has to survive. After that, we'll look at the daily checklist for every unit coming off the line. And we'll wrap up by talking about why this work makes you a true guardian of the grid.
All right, first up, the rulebook. To make sure every inverter is not just safe, but also performs the way it's supposed to, the entire industry relies on a very specific international standard. This is the bedrock for all the testing we're about to talk about.
And that standard is IEC 62109. You really need to know this one. Think of it as the global gold standard for inverter safety. It's so foundational that in places like India, their mandatory BIS certification is built right on top of it. You could say it's basically the law of the land for inverters.
Now, this standard splits testing into two main types, and the analogy is pretty simple. On one side, you have the type test. This is like the massive, comprehensive final exam a brand new inverter design has to pass just once to get certified. On the other side, you've got the routine test. This is more like a daily pop quiz that every single unit, and I mean every unit, has to pass before it's allowed to leave the factory.
So let's dig into that big final exam first, the type test. This is a whole series of really high-stakes challenges. They're designed to push an inverter to its absolute limits, to prove that it is fundamentally safe, and of course, that it works effectively.
The very first, and maybe the most critical challenge, is the dielectric withstand test. So after you've safely isolated the unit, using lockout/tagout or LODO procedures, we hit it with an extremely high voltage. We're talking several thousand volts, and we hold it there for a full minute. The whole point is to make 100% sure the inverter's insulation can handle a giant voltage spike without failing, which is what prevents a potentially deadly shock.
And here's the bottom line for that test. The amount of current that might leak through the insulation has to be less than or equal to 5 milliamps. That's it. Anything higher, and the design fails, period. It's a simple, non-negotiable safety line in the sand. Next up, something called anti-islanding protection. This is a huge safety feature. Picture this. The power goes out in your neighborhood. A utility worker shows up to fix the power line, and they're assuming that line is dead. Well, this test makes sure that if the grid goes down, the inverter instantly stops feeding power back into it. It has to shut off within 2 seconds. This feature literally saves lives.
Now, beyond those huge safety checks, the type test also makes sure the inverter actually performs well. Is it efficient? Is it converting at least 96% of that DC energy? Is its maximum power point tracker, or MPPT, accurate enough to stay within 2% of the real sweet spot? That's how you squeeze every last watt out of the panels. And finally, is the power it's sending out clean, with distortion below 5%, so it doesn't mess with the grid? The answer to all of these has to be a resounding yes.
Okay, so that was the big, one-time exam. Let's switch gears now and talk about that daily pop quiz, the routine test. This is the hands-on, practical checklist that makes sure the high quality of the original design is perfectly replicated in every single unit that rolls off that assembly line.
And this right here is your main tool. This checklist gets run on every single inverter. We're checking the basics, of course, like making sure the labeling and wiring are right. But look closer. We are also doing quick-fire versions of those big safety tests, like checking insulation resistance, and yep, there it is again, that critical 5 milliamp leakage current. Every single one of these boxes has to be checked pass before an inverter can even think about being shipped.
So, let's bring this all home. Following these procedures isn't just about checking off boxes on a list. It's about understanding the absolutely crucial role a technician plays. You're not just a tester.
You are a guardian of our entire energy infrastructure.
Because, when it all comes down to it, this is the reality of the situation. Systematic testing is the wall that stands between a project that runs smoothly and makes money and one that's just riddled with failures and safety risks. It's the absolute backbone of professional quality control and, frankly, a non-negotiable for any serious company.
And I really want you to remember this. Every single time you follow that checklist, every time you calibrate your equipment, every time you carefully record your results, you are laying another brick in the foundation of a safe, reliable, and sustainable energy future. Your diligence, your attention to detail, it really, really matters.
And that kind of leaves us with one last thing to think about. As inverters get smarter and solar tech gets more and more woven into our daily lives, what do you think the next frontier for testing is going to be? What are the new challenges we'll need to solve to keep up this level of quality and safety? It's definitely something to chew on.